our session. Today we have Cho Talebi. He's like a AI scientist, educator. He's one of my favorite YouTuber in the AI community, in the AI field in general. He's having a PhD from the University of Texas at Dallas. He also worked as a data scientist at Toyota Financial Service Corporation, and he has like a very he has YouTube channel, newsletter, blog, and also he run his own courses. So we are very happy to have him today, and he will talk a little bit about one of the very attractive topic, the MCPs, and how to build your custom, as you can see, how to build your custom AI agent with MCP. So welcome, Joe, and thanks for accepting my invitation and like giving us some time to deliver this talk.
Yeah, well, thanks so much for having me. Thanks for the introduction. Thank you guys for joining on a Sunday or a Saturday evening, depending on where you're calling from. It's 8 o'clock for Yusuf. It's 1 p.m. for me. So, I guess you got nothing better to do on a Saturday than listen to me talk about MCP. But before we get into that, I guess Yusuf gave a brief intro, but here's a little background about me. I got into AI about 7 years ago when I was in grad school. I was an applied AI researcher. After that, I went on to industry, where I was working as a data scientist at Toyota Financial Services, as Yusuf was saying. But more recently, I've been on this entrepreneurial journey, which has meant a lot of different things. So I did AI consulting for a bit, helped over 100 clients. Also, as Yusuf said, I have a YouTube channel and also have a technical blog. Excuse me. Have almost 100,000 followers across there. Made a lot of content. Also have a course on Maven that I teach. Helping people build AI products, AI SaaS things, AI projects. And also I've been building my own AI SaaS products. I have a couple products out there. One's called Y2B. Another one I just released last month called Ghostwriter. And so very much.
I really like your initiative, like building. I think it was 30 SaaS application in 1 month, or
Yeah, exactly. So,
yeah.
my whole philosophy is building a startup, building a product is hard. You're probably going to fail. Most startups fail. And just doing the math, you got to do some statistics. If your probability of failure is 95%, how many shots on goal do you need to make in order to, have a strong probability of success? So you can just do some math and you can come up with a number. So I decided to just go on this journey of building 20 AI products because, if I build 20, hopefully one of them is going to be successful. So that's the journey I'm on, and just trying to do this as quickly as possible. So for Y2B and for Ghost, like both of these products, I built them in 30 days, like built and launched them, and just learned a lot in the whole process. So I would give that advice to anyone who is also interested in like building a SaaS or building AI products, especially as like a solo founder. Just have a bias toward action and building. Don't just like sit around for the perfect idea. You're not going to find clarity sitting around trying to ponder and think about it. You're going to find clarity through action and doing it. So I couldn't recommend that enough. Anyway, but let's talk about MCP. So MCP's kind of been growing in popularity. It was released about 11 months ago from Anthropic, and it's now maybe a little bit of a buzzword, but also it is something that people are using in a wide range of contexts. So everyone from AI users using it with like ChatGPT or Claude, all the way to very serious 10x engineers building custom MCP servers to help them code faster. So and everything in between. But you might be wondering, what is this MCP thing that everyone's talking about? And simply, it's a standard way that you can connect tools and context to AI applications. And so the analogy that Anthropic gives for describing what MCP is that it's kind of like the USB-C port of AI applications. So I guess if you're a little younger, you won't remember this time, but like back in 20, even 10 years ago, if you wanted to connect a device to a computer, there was basically like a custom port for that device. But over time, the ports got standardized, and now we have the USB-C port. So basically, you can plug anything into your laptop. You can even charge your laptop all with this single port. And that was the vision of MCP when Anthropic released it. So basically, why can't we have a single port that we can use to power our large language models, our AI applications? And so, just to make this a bit more concrete, there are a few, here are a few specific use cases of MCP. So the simplest way you could use it is just connecting, creating these custom integrations with your favorite AI apps. So, for example, you can connect Slack or Google Drive to Claude Desktop. So basically, you can give Claude access to your Slack channels. You can even give it the ability to send Slack messages. You can give it the ability to read your documents in Google Drive. You can also allow it to create documents in Google Drive. So there's endless possibilities even with this simple integration. You can also create custom AI applications and AI agents by just going and finding MCP servers on the internet and connecting them to your favorite large language models. Whether that's having it think longer, doing file search, searching the web, whatever it might be. And then going one step further, you can also build custom tool sets, custom MCP servers, as we'll talk about in a little bit, to create custom AI agents and applications. So there are countless different ways people are using MCP and ways you can use MCP, but here's just a flavor of what that might look like. Okay, so we've talked about what MCP is and what you can do with it, but I want to briefly talk about how it works under the hood. Just going one level deeper than the high level description. And basically, under the hood, MCP uses this very common architecture, which is a client server architecture, which you'll see all over the web. So basically, to give an analogy, this is kind of like if you were to go to a coffee shop and order a drink from a barista. So basically, you can think of yourself as the client, and you can think of the server or the barista as the server. And the way this works is that you, as the client, will send a request to the server. So you could request something like, "Can I get a pumpkin spice latte?" And then the server will send back a response. So they'll say, "You got it," and give you the latte. And so this is essentially how MCP works as well. But instead of a client at a coffee shop and a server behind the counter, you will have an MCP client and an MCP server. So the MCP client will send a request to the server, and this will be something like, "What tools do you have available?" And then the MCP server will just send back a response with a list of whatever tools it has. Okay, so this is a high level overview of how MCP works. Now I want to just dive into each of these two components of the client and the server. So starting with the client, this is something that's going to be built into the AI application, and it's going to send requests to and from, it's going to send requests to the MCP server and receive responses, receive data from it, and pass it to large language models. So, for example, you can consider Claude Desktop, which is an AI application. It allows you to interact with Anthropic's Claude model. And within Claude Desktop, there's an MCP server that will communicate with the LLM and can communicate with external MCP servers. So you have an MCP client within Claude Desktop, and it communicates with MCP servers. You can also have multiple clients communicating with multiple MCP servers. So, using the example from earlier, one server could be a Slack MCP server, another could be a Google Drive MCP server, and then maybe another one is a Gmail MCP server. So you're fully integrating Claude into your day-to-day workflow. And so some of the key responsibilities of the client are to, one, discover server capabilities. So basically understanding what the server is able to do. It's able to send Slack messages. It's able to fetch documents from Google Drive. It's able to send emails. receive data from servers. So, the LLM might be calling a tool saying like fetch email, like fetch inbox or something like that. So the client's going to pass that to the server, and the server will respond with all the emails in the person's inbox, for example, and also managing the tool execution. So actually, taking the text that the LLM generates for the tool call, passing it to the server, and getting back the response. Um, then the other key component here is the server. So this is what's going to listen for requests from the MCP client and respond accordingly. So again, we have this picture here of our MCP client and MCP server working with Claude Desktop. And the server here is going to have three key features. One, it's going to have tools within it. So these are things like Python functions, maybe if you want to call an API, or you can do arbitrary things like image processing. Servers can also have resources. So you can think of this as like a database or a file system. So basically, just data or context that you might want to make available to a large language model. And then finally, it has prompts. So basically, pre-written instructions that you might want to give to your LLM. And then the final thing I'll just mention is, there are two ways you can have clients and servers talk to each other. You can have everything run locally on a laptop using, standard I/O, or you can even have remote MCP servers communicating with AI applications with MCP clients using HTTP. Okay, so that's kind of like a whirlwind overview of MCP and what it is. But now I want to make things a bit more concrete by walking through a concrete example. So all the code for this is available on GitHub, and I can share the link to that, or maybe Yusuf can share the link to that in the chat.
Sure, yeah.
Yeah, in chat here. Um, but yeah, basically a high level overview of what we're going to do here is, basically here's me with a mustache and a lot more hair. And I'm going to, send a request to a large language model. But I want this large language model to be able to access YouTube transcripts and have specialized instructions for doing things like, maybe turning YouTube transcripts into chapters, timestamps, generating blog posts based on YouTube videos, generating social media posts, answering questions about the YouTube video, or even like creating a curriculum based on a set of video links that I give to the LLM. And so basically, we're going to make this possible by building a custom MCP server that comes out of the box with various tools and instructions. So the final result of this is that this YouTube agent will be able to extract transcripts, generate chapters, write blog posts, and just do arbitrary tasks that we might want to do with YouTube videos. And so I'm going to be using GPT-5 for this example, and then this will be, and I'll be using OpenAI's Agents SDK to build out the use case. Okay, so just to give a brief overview of the key steps here. So the first thing we're going to do is create the MCP server, which is actually very straightforward using Anthropic's official Python SDK. Then we're going to add a prompt and tools to the MCP server. Then we'll set up this local transport so it can all run on my laptop. Then we will create the agent, via the MCP server. So basically, we'll just take this MCP server and give it to GPT-5 to create our agent. And then finally, we'll interact with the agent. Okay, so step one, creating the server. So let's see. We're going to start with some imports. So the key things here are this first import, which is from this MCP library. So this is Anthropic's official Python SDK. So I will say there are a lot of like MCP libraries out there now that are not from Anthropic. So just like from third parties. So I would just be mindful of what library you're using to build your MCP server, or use if you're trying to use MCP servers. It's a good thing to keep in mind. So we're going to import this class called FastMCP, which, as the name suggests, will allow us to build an MCP server very quickly. And then the next key import is this YouTube transcript API class from this YouTube transcript API Python library. And this, as the name again suggests, allows us to fetch transcripts from YouTube videos. Okay, and so to create the server, we can just use this fast MCP class and give it a name. And just like that, we have our server initialized and ready to basically add things to it. So now we can add stuff to it. So we'll first add a prompt. So the way you add prompts, tools, and resources to MCP servers is, using this syntax here. So basically what you're going to do is create a custom Python function, and then you'll just add a decorator to that function to tell the MCP library whether the thing should be a prompt, a tool, or a resource. So if it's a prompt, we just do @mcp.prompt, and then I'll call this function system prompt. So it'll take no input arguments and it'll return a string. And all this, I know it's like a little fanciness going on here, but the bottom line is all that's happening is that it's searching the local directory and it's finding this file called systeminstructions.md. So it's a markdown file. And then it's going to extract all the text from that markdown file and make it available to the large language model, or to the large language model or the AI application, depending on how you build your software. But just to give you a little glimpse of the system instructions here, so we just some basic instructions. You are a YouTube video agent. You help users with requests related to YouTube videos, and then we have some rules, and we list out the tools and how to use the tools and some important notes. So if you want to read this whole thing, it's on the GitHub repository, which I think Yusuf shared, and also all the code is on there as well. Okay, so that's the prompt. The next thing we want to do is add tools. So I'm going to actually add two tools. The first one is called fetch video transcript. So notice that now we use the decorator mcp.tool instead of mcp.prompt. And also we have an input argument here. So we're going to take in a URL, which is going to be a string, and we'll again return a string. And so notice that the doc string here is actually it's longer than the previous example. And that's because, and that's actually a very important note, because this doc string is what's going to be made available to the large language model when it's trying to decide whether that tool is going to be helpful for a specific user request. So the more details and more guidance you give in the doc string, hopefully the better the LLM will be able to use this tool. And so we're describing what the URL, the input argument is. So it's a YouTube video URL. And then finally, we have its returns, which is just describing what the LLM can expect to get from this function, which is a formatted transcript with timestamps, where every entry is on a new line in the format of this. So it has the timestamp and then the text from that timestamp. And so this is important because the LLM needs to know, what do I need to pass into this function, and then what can I expect to get out. And so I've kind of omitted the actual Python code just because it's quite long. It wouldn't fit on the slide. It's all on the GitHub though. And then I created a different tool called fetch instructions. And what this is going to do is the LLM can pass in one of three input arguments. So either write blog post, write social post, or write video chapters. And in return, it's going to get instructions for that specific task. So basically, these are just common tasks that we might want our agent to do, and they're going to require some specialized instructions. And so it's better to kind of have these available to the LLM on demand, as opposed to trying to shove everything into the system prompt and just muddying up the context window unnecessarily. Okay. So step 3 is setting up the local transport. So this is actually super trivial. We'll just do, we have our MCP variable here. So that's the server. And we'll just do this .run method. and then we'll specify the transport as standard IO. Okay, so the next thing we're going to do is create the agent with the MCP server. And so this is maybe a little, so this is a little more complicated than the MCP, like creating the MCP server. And I'll just say, like, you don't have to, if you wanted to, like, get this functionality, instead of just building a custom agent like we're doing here, you could just take this MCP server and plug it into Claude Desktop and basically get the same results. And I have some example code for that as well, which I can share after the talk. But here I'll just kind of show what this might look like if you're trying to build a custom agent using OpenAI's Agents SDK. So the first thing we'll do is import our OpenAI API key. So I do that using this python.env library, and then I have my OpenAI API key in a .env file. So this is just going to load in all the environment variables from this file. And then the next thing we're going to do is load in the MCP server. So again, there's some fanciness going on here, but the key thing to look at is we're going to import the server using these params here. So it's doing a UV run MCP server yt-mcp.py. So we'll look at the directory later, so this will make more sense. But essentially, what's happening is we're passing in a command line, like a command line command, and what's going to happen is whenever this app spins up, it's going to spin up a sub process that's going to run this command uv run and essentially run the MCP server as a sub process so that the agent, the AI application, can interact with the server, while it's working. And the reason we do with is just to handle if the app unexpectedly shuts down, we don't have the MCP server still running, even though the main application stopped running. And then here, I also create a trace. So this is more for like debugging purposes. So you can have the entire conversation and history of tool calls and all that kind of stuff in a single trace. And then we can take a look at it in the OpenAI dashboard. So we'll see an example of that later. But actually, to create the agent itself is very straightforward. So we'll just use this agent class from OpenAI's Agents SDK. We'll give the agent a name. We'll give it instructions. And so I'm actually importing the instructions from the MCP server. And then finally, we'll just give it the MCP server that we want it to use. And then probably the most complicated part of this example is creating the command line interface. But you can just steal the code and you don't really have to worry about the details. And just for interest of time, I'm not going to go through that here, but all the code's on GitHub if you like. Okay, so step 5 is we can actually interact with the agent. So I'll go to the terminal here. I'll zoom in. Let me clear this out. So actually, I'm going to do this whole thing from scratch just so you guys can see how easy it is to get set up. So here's actually the GitHub repo. And I guess Yusuf already shared it, so I won't. Let me just make sure. No, maybe not. So here, I'm going to just copy paste the GitHub repo. And what I'm going to do is copy this URL to the clipboard. Then I'll go back to my terminal and I'll do git clone. And then I'll paste this in. And then we can do an ls. And then we'll see I've now got this folder, YouTube MCP agent. So I'm going to go into this folder. And then we see we've got, basically the repo, but now locally on my machine. And then I'll just do a UV sync to get all the dependencies installed. Super easy. So if you haven't used UV, I highly recommend it. It makes life a lot easier, as you could just see. And now to actually run the agent, let's see, we have this main file here, so main.py. So I'll just do a UV run main.py. And then we'll get this command line interface. So you see the trace is automatically Oh, I need my OpenAI API key. So this is kind of like the joy of live demos. So let me actually go find one real quick. Let's see. I'll go here. Um, I think it'll be maybe this one will have it. Yeah, this one has one. So I'll copy this and then I'll go back here. Yeah, so you'll need a .env file, and in that .env file, you'll need your OpenAI API key, uh, defined. So let me just type exit, and then I'll clear this out, and then I'll do the same thing. Okay, so this should be working now, and we'll be able to look at the trace. So let me just copy this and I'll paste that here for later. But let me grab a YouTube URL. So let's see. These are the latest ones. I have one on MCP. So let me go to popular, and we can be a little meta. So I'll. Oh, this is getting blocked. Let's see. Yeah, so I'll click share. I'm going to grab this link, and then I'm just going to paste this here and say something like, "What is this video about?" And then we'll see that I guess the agent is thinking. And then it called the fetch transcript tool, and then it completed the tool call. And then it says, this video presented by Shaw is the fifth in the series on AI agents. And it's just going on and on and on about what the video is about. And it's cool. It's giving like timestamps, and it's giving references. So the reason that it's like giving these timestamps and references is actually if we go to the MCP server and we go to the prompts. So these are the system instructions that we included in the MCP server and ultimately gave to the AI agent. And we have this core rule here, which is always cite and link to specific parts of the video used in your answer. So this is a kind of a programmed trait, a programmed behavior of the system. And of course, the great thing about LLMs is that if you want to change the behavior of the system, you can just do that with English or really any language you like. You just put it in the system instructions. But then we could do something like, write me a LinkedIn post about, let's see, about MCP servers. And then we'll wait, and then we'll see that the agent called another tool. So it actually fetched instructions specifically for writing a LinkedIn post, and then it wrote out a post. And then it even like cited things, and then it linked the full video, which is pretty cool. And so we can go look at the social post instructions. So we see that here we have like guidelines for writing LinkedIn posts and engagement tips and things like that. So maybe if we don't like how the agent wrote the post, we can go into these instructions and update its behavior. So that's basically it. But the last thing I wanted to show is this trace here. So we can look at the full conversation, like the full trace of what this AI agent was doing, using that trace link from earlier. So you notice that like the first thing the agent does is that it lists the MCP tools. So this is like a standard behavior. And then we can see that we had this, so we had this initial request, which has the system instructions, and then it has that initial request that we sent. So we have the YouTube video link, and then we had what is this video about, and then we see that the agent GPT-5 just called the tool immediately. It didn't, it thought for a little bit, and then it just made this function call, and then the agent's SDK just automatically handled this function call. So it got this text from the LLM, and then this is the output. So we have the full transcript here, and then the agent lists the tools again. And then now that the agent has the full transcript, it's able to generate an output, and then this is the output that we got. And then it did a similar thing for the second request, which was write me a LinkedIn post about MCP servers. And then again, it just immediately calls this it calls this function fetch instructions, and then does a similar thing, and then we can see the full thread here. Okay, so that's basically it. Now, happy to take any questions you guys might have. I see there are a bunch in the chat, so I'll just go through these
Yeah,
one at a time.
yeah, exactly. Thank you very much for the demo and for the session. And yeah, we can go to the questions now.
Let's see. I don't know. Do you want to?
I think we have 4 questions.
Okay.
Yeah, we can start by the last one. How the LM gets the right instruction for each client request?
Yeah. So just how the just how like ChatGPT can handle like arbitrary tasks, this agent will be able to handle arbitrary tasks. But if the user is asking for something specific, like write me a social post or whatever, we in the system instructions, we go here, we kind of specify that it has access to this fetch instructions tool. And then, the LLM is smart enough to figure out that if the user is asking me to write a blog post or a social post or video chapters, that I should use this fetch instructions tool. So the LLM just kind of like figuring that out from the system instructions.
Yeah, cool. We have 2 questions from Feedback. I think the first one is he's saying we have 3 questions actually. The first one is it possible to discuss a little bit about how to evaluate these agents?
Yeah. So evals are something I kind of think about at different stages. So when you're going from 0 to 1, like you're just building this thing for the first time, the place I would start is vibe checks. So basically, I would just have the agent do random tasks that I'm thinking about, and then I would go through and I would have the agent just do tasks like this, and then I would go through and just read its responses and see how it does. Like, does it kind of pass that vibe check, that gut check? And if it doesn't, like for example, I don't really like this LinkedIn post. It's like it doesn't feel like a LinkedIn post. So I can like read it, and then I can go over to the write social post instructions, and then maybe I'll tweak it and then try again. And so I'll kind of do these like vibe check, ad hoc fixes just until I get to the point where it's starting to behave good enough on just these random tasks. But that's just to go from like 0 to 1 to start like scaling this evaluation process. What you really want to do is think about like, okay, what are all the different ways users are going to use this? And ideally, you have real user data to answer that question. But if you're just building this like we are here, you're just going to have to use your own intuition and expectations. So maybe I'll say, okay, people are mainly going to want to, ask questions about ask questions about the video, generate chapters, write social posts, write blog posts, and just like come up with a set of tasks. And then I'm going to come up with a set of like inputs to the system that correspond to that task, and maybe like a few inputs for each task. And then I'm just going to build this pipeline to kind of automatically run those inputs through the system, generate the traces, and then I'll go through and just manually review like 100 traces and annotate those traces with like free form instructions using error analysis. So I guess it'll probably be a lot to try to explain right now. But I talk about error analysis in this video, and I go through a concrete use case. And basically, you're just going to do the same thing. So I'm going to drop that in the chat in case it's helpful.
Yes, thank you. Also, he was asking about is the trace function in OpenAI SDK can be used when we are using LangGraph, if we are like developing the agent with LangGraph or not.
Can you use the MCP server in LangGraph? Is that the question?
I think he's asking about the tracing in OpenAI SDK.
Oh yeah. So here we get traces, and then we can look at it in the OpenAI dashboard. You can do a similar thing with. I don't think it's Lang. So LangChain has a service called LangSmith that allows you to view the traces and do this process that I was describing of like doing the annotations and adding labels to things like that. So yeah, that's a great tool for doing evaluations. You know, I kind of default to just like building custom data viewers, but if you want like off the shelf solution, LangSmith seems like a good one.
Yeah, he's also asking, can we restrict the agent to only call the tools and not act as a general chat
Yeah.
GPT or general?
So you can. So the first thing I would try toward that end is to put it in the system instructions.
Mm,
You know, if you don't want it to just say like only answer questions relevant to YouTube videos and so on and so forth. So that'll. I mean, of course, that won't be perfect, but that
mm,
will handle a lot of like basic cases. Um, then, if you want to force the agent to use tools, you can do that. So if we go to the code here, we go to main, um, and then here, when you create the agent, there's a flag you can call. Like there's a property that basically forces the agent to call tools. So let me see if I can find this real quick. Tool call force. I don't know if I'll be able to find it here. Actually, I know where I can find it. So let me go to my repos. Go here, session 4, a YouTube agent. Maybe it's this one. Where do I put it? I think it's here, not this one. I think it's the Notion agent. Yeah. Okay. So there's this attribute. Uh, so you can adjust the model settings and the tool choice, and you can set it to required. So this is going to force the agent to make a tool call every time the user sends a request. So you can kind of, try to, maybe get another layer of, constraint of the system through this. But of course, like there are going to be those cases that leak through, and if it is like a big problem, that's something you're going to have to kind of go through this like eval process. Let's eval flywheel to get to remove that behavior from your system.
okay. We have, I think, two or three questions more. First one is, do you think like we can use small LM like around 4 billion parameter that can be downloaded and run locally for this type of agents?
Yeah, for sure. I think because a lot of the work here is, it's in the transcript.
Mm.
Maybe the social posts and the like blog posts wouldn't be super good, but if the main use case here is just information retrieval from the transcripts, I think it'll actually work very well.
Yeah, and another question we have is, can we build this in JavaScript so we can expand the?
So if you want to build the custom server in JavaScript, oh no, what am I doing? MCP server. If you want to link, Yeah. So is this the right? No. Yeah. So they have a. Oh, maybe they don't have a JavaScript SDK, but they do have a TypeScript SDK that you can use. Um, yeah, maybe TypeScript is going to be the best option, or maybe PHP if you're familiar, if you're comfortable with that. So you can build the MCP server there, and then as far as the like actually building the LLM, I'm not familiar with the JavaScript libraries for building AI applications, but you can definitely call OpenAI's API using JavaScript. So maybe it's going to require you to build a bit more like scaffolding, more boilerplate code, but you can definitely do it.
Yeah, we have like another question. Can we connect the LM to our private tool or application like OCR or whatever?
Yeah, so you can basically build an MCP server. So, okay, what is an MCP server? It's just giving a it's just making available arbitrary Python code to your LLM. So, if you have proprietary tools, internal tools that you can uh, make available or at least call using Python or one of these programming languages, you can build an MCP server that has all your internal tools available to it. And now you have this artifact you can give to virtually any large language model or any AI application.
Yeah, last question. Each MCP client can handle only one MCP server. Is this correct or not?
Yeah, that's right. Um, and yeah, I guess like, most times. So, like, notice here when we spun up the agent, we didn't have to create the client. You know, OpenAI's Agents SDK handled that for us. So we
Mm.
could have, if we wanted to add multiple MCP servers, we just add them to this list here. So it's actually pretty trivial to add multiple MCP servers. And it's a similar thing with like if you're adding them to Claude Desktop or Cursor or something like that. So I haven't like I guess the only time you would need to build MCP client is that you're building a custom application and then you want the data to get passed to the LLM or be handled within the application in a very specific way. But generally, you probably won't need to build a client. If you're one using an off-the-shelf application, or two, you're using one of these like frameworks, like you're using a library like OpenAI's Agents SDK or LangGraph or something like that.
Awesome, thank you. Um, yeah, a lot of people are telling you thank you for the session. So
Yeah,
yeah,
for
yeah.
sure.
Yeah, I think this is the end. Thank you very much for your time and for the demo and for the question for the answering the question. If you are watching this session on YouTube, you'll find the all social links to show and also the code repo in the description. And if you are attending live with us now, you'll get all of this to your email after the session also. Thank you everyone, and hope we can see you in a new session. Thank you.
Thanks, everyone. Have a good weekend.